You will most likely see a problem similar to this on your 6.2 quiz, and these show up on the test from time to time. The first thing you may try is to use the denominator, which is often a good bet, to choose the denominator to be your u. But you notice when you then find du that you're going to get 0 plus 32r dr. And the 32 we can fix. It's not there, but we could fix it if we needed to. The r, however, cannot be fixed. I don't have an r in the numerator to burn up in that u substitution, so I'm going to have to try something different. When you get that pattern, a lot of times what you want to do, there are no radicals in there, is set up 1 over 1 plus u squared du, because the antiderivative to this pattern is arctangent. But we have to set this up. The easiest place to work is, or to start, is to fix the 1. And the corresponding number over here is the 9, because it doesn't have a variable attached to it. So I want to make a 9 look like a 1. And the way you do that is to have 9 over 9. But you can't just randomly divide by 9. Another way that you can divide by 9 but not get rid of it is to factor out a 9. So if I factor a 9 out of these two terms right here, 9 divided by 9 is 1. And then I need 16r squared also divided by 9. Everything here is still in terms of r and dr. I have not made any substitutions. So in the next step, I want to work on the u squared. So I need a quantity that's squared, and that's going to come from the 16r squared over 9. Notice the r is squared, the 16 is a square number, the 9 is a square number. So I'm going to rewrite that as 1 plus 4r over 3. Just take the square root of each of those and then square it like that. Now notice if I apply the square to what's in parentheses, I get back to 16r squared over 9. If I multiply everything by 9, distribute the 9 through there, then I'm going to back right up to here. So nothing has changed, it just looks different. Now I want to use what's in parentheses right here for my u, because then it will fit this pattern other than these numbers, which are just constant multiples that I can factor out to the front. So I'm going to take u equals 4r over 3. When I find du, it's going to be 4/3 dr, 4/3 dr. And so the 4/3 needs to be fixed. I have 7/9 right there. I need to have 4/3 rather than trying to manipulate that. I'm just going to deal with the 4/3, which means I also have to multiply by 3/4, the reciprocal, and then I'll just deal with the numbers themselves. I don't need these numbers in here to do my substitution, so I'm going to bring them out to the front. So I have 3/4 times 7/9, and when I rewrite my integral, in the dr 4/3 is going to become du, and there's nothing left in the top, so I'll write it there. And then the 9 I've already moved out, and I have 1 plus my 4r over 3 is u, and that quantity is squared. So my integral part looks like this, and my fix for the constant is out in the front. I can reduce this. The 3 and the 9 are going to reduce this way, so I'm left with 7 over 12. And now I know that the antiderivative of this integral, or this integrand, is going to be the arctangent or tangent inverse of u. But I also know that u is 4r over 3, and I just need a plus c.